Yeah, thanks, Mark. So yeah, hi everyone. Welcome to this 9 to 10 session. I'll be presenting the cell struct homework. So for this homework, I'd say it's quite a challenging homework. So make sure you're getting started early on this homework and also on the module because the modules are pretty long and there are lots of quizzes and everything. So make sure you have the time to really understand what's inside the modules before starting the homework, and make sure you start the homework really early. So in this module, you learned about two new objects in MATLAB, the cell and the struct arrays. So make sure you understand what they are, and I'll be throwing here a few notes, like what I think is really important you understand about the cell arrays and struct array before beginning the homework. So if C is a cell array, make sure that you understand the difference. Yeah, so I'll be going over the problems in the discussion, and there will be time hopefully after the discussion to go over some problems, or there will be a GSI at 10 that will be answering your questions. So if C is a cell array, then make sure you understand the difference between C of 1 and inside parentheses and C of 1 inside curly brackets. So C of 1 gives you gives the cell array, so gives the cell located at um, index 1, so the first cell of the cell array C. So C of 1 gives you basically like the container, the box that's at index 1, and C of 1 inside curly brackets gives you the element contained in the first cell. So like C of 1 inside parentheses gives the cell, so the box, and C of 1 inside curly brackets give you what's inside the box. Like it could be a char or a character, or it could be a number or anything, right? Um, make sure you also understand the comma separated list that you will be using a lot during the homework. So during my presentation, I will be referring to comma separated list as what I just wrote. So %CSL %. Each time I write that, you will have to write a comma separated list inside the code. So for example, 1, 2, 3, 4 is a comma separated list. So if you put this comma separated list inside an array, inside these types of brackets, you will have a double array. And if you type this comma separated list inside the curly brackets, this will give you a cell array. Okay, so make sure you really understand that. And also remember that when you have a structure, like for example, let's say that if S is a struct and if S has field name fname, then s.name is a comma separated list. So you can use this comma separated list inside curly brackets to have a cell array, or inside the other type of brackets, which would give you a double array, right? So remember that, and this will help you throughout the exercises. And my last advice would be that before writing the functions, before directly typing inside your functions, make sure that the different lines are working on an example, right? So before directly starting writing the function, test each line with an example. So starting from exercise 2, you have already examples provided inside the homework, but and I will be providing you an example for exercise 1. Okay, so let's get started on the first exercise, which is the gradebook exercise. Okay. Okay, so in exercise 1, you're given, so you're not given, but gradebook is representing a structure with n elements, and each element represents a student, and the structure has two fields, right? So the field name and the field array task scores. And you are asked to write a function that's returning the same structure, but with a new field, which is the field weighted task score, which will contain the weighted average of all the scores for each student. And second, you're asked to return the names of the students that have a weighted average bigger than 90. And these names will be contained in a cell array. So as I said, the first step is to, I would say, like the step 0 to make sure that you're approaching this exercise well is to create a gradebook object. So I've created one for you here. So the first thing I do is create a cell array with 5 fields, and these fields contain the name of 5 persons. So here is your GSI. And I also create the array task weight, which will give you the weight for each grade. And then I create also the cell array C task scores, which is a cell structure, and each element contains 1 by T vector. So here T equals 3, right? Because task weight has 3 elements. And so each element of C task scores, it's a 1 by 3 random vector containing numbers between 1 and 100, basically. Okay, so each element of C task scores is gives the grades for the corresponding element of C names, for the student in the corresponding elements of C names. Okay, so step 0 is create an example, and here as suggested in the file, I use n equal 5 and t equal 3 here. Okay, so the elements in red are pieces of code that you can directly copy and paste into your MATLAB session. And so this will give you a gradebook element that you can directly use to test whether your lines of code are working or not. Okay, so once you have this gradebook element, the next step, so step 1, is to go over the different element of the structure array gradebook. So this will give you so this will be given by gradebook of k dot field name. So for example, if you want to access the name of the first student, it is given by gradebook first element dot name. Okay, and if you want to access the task weights of the first student, we'll be writing gradebook1 the task weights, etc. for the second student. Okay, so you will be considering in that case the task weights for each student, and what you will be doing is that for each task weight you will be multiplying the elements. So for each element of uh, gradebook, you will be multiplying element by element the array gradebook K array task scores, and with the elements of task weights. Okay, and this will give you the weighted scores for each score. And then once you have the weighted scores, you can just sum the elements of the array you just computed, and you can store this value in the new field that's called weighted task score. Okay, and once you have that, you can return the argument gradebook weighted. Okay, so make sure before you write the function that all the steps that you wrote don't have error. So use the example gradebook that I gave you to make sure you don't have errors in your different steps, because it can be confusing when you first manipulate cells, whether you should be writing curly brackets or the other type of brackets. So make sure everything is working, and then when you see it's working, you can compute the function. Okay, and the second step is to create the cell array of the names that have a weighted average bigger than 90. So let's focus on that. So I would suggest here the first thing you do, because you're asked to give names, is that you create a cell array containing all the students' names. So for this one, you will be writing something like cell array names equal a comma separated list inside curly brackets, and so this will give you a cell array, and the comma separated list will be something that you can have from the gradebook struct. Okay, so I'll let you think about that. And so once you have the cell array containing all the students' names, the next thing I would do is containing this time a double array, is creating a double array containing this time the weighted scores for all the students. So the line you'll have to write here is very similar to the line you wrote just before, except that you will be writing your comma separated list within the straight brackets, and so this will give you an array containing doubles. Okay, and this array will contain all the weighted averages of the students. And because the comma separated list keeps the order, the first element of weighted score will be the weighted average corresponding to the first name, to the name contained in the first element of cell array names, and the second element of weighted scores will be corresponding to the second name of cell array name, etc. So then the next thing is to find the elements of of weighted scores here that are bigger than 90. And once you found these elements, you can select the corresponding names from cell array names. Okay, and here it's required that you don't use loops. So no loop, and so you can directly compare the array weighted scores that you computed just a step before, and directly compare weighted scores with the double 90. Okay, so Mark, I hope that helped you with setting up this first exercise. So I'm done talking about exercise 1. So let's move on now to the next exercise, which is the exercise word index. Yeah, sure. I'll be coming back over these exercises after the discussion, if I have time. Okay, so let's talk about the word index now. So the index will be a 1 by n struct array, where n is the different words that live inside this index. And index will be having 3 fields. So the field word corresponding to the giving the word that's contained in the index. So giving the word that's located at location k of the index. Then the second field will be the document. So document is a 1 by something double, and the something will be the numbers of different documents that contain the word that we're talking about. And the third field is the locations containing the index, so containing the location of the word that is considered within the document considered. Okay, so in exercise 2, you have to write a function that is called initialize index, which will basically create the index structure, the empty index structure. And so for exercise 2, it's quite easy because you have all the code, so you don't have to do anything more. So this should be the easiest exercise of your whole MATLAB life. So the code is given. So once you write the code, make sure that you understand what the so make sure you understand how you can manipulate the so how you can manipulate the object. Okay, so make sure you understand what the object is and how you can access the different fields. Okay, but exercise 2 shouldn't be giving you too much trouble, right? Okay, so let's go to exercise 3 now, which is trickier. Okay, so for exercise 3, you'll have to write a function that is called insert doc, and that will be updating the index that you wrote in question 2 with new documents. So the statement for the function is pretty long because they give you a lot of examples to be sure that you understand what you have to do. But don't worry, the the function will not be that long. It will be like about 20 lines or something like that. So it's still a challenging function, but don't be afraid by the length of the question. So the first argument of the function insert doc is, oops, sorry. So the first argument is an already existing index, and what you want to do is update this index with the new document that is given as a second argument. And the third the third argument is the number that is so the number of the number corresponding to new doc. Okay, so new doc, it's stated that new doc is a cell array 1 by W, when W is the number of words. And so in your function, what you want to do is consider all the elements contained in new doc. So all the different words that are contained in the document. And you want to update the index with every word that is located within new doc and curly bracket K, which will give you the word contained at location K of new doc. Okay, so each time you'll be looping over, you will be considering a new element of new doc. You'll be basically considering a new word, and for every new word you want to check whether the word is already contained in the index. So the next step when you're considering new doc of K is that you want to compare new doc of K with the words that are already contained in the index. So yeah, you will be going over every word in new doc, and you will be comparing every word with the other words that are already contained in index. So to do that, you want to first see if new doc of K is already contained in index. And second, if it is contained, you want to find the corresponding index. Yeah, it's the same word, but you want to find the corresponding element of index that contains the word new doc K. So Varen, I will be going over that. So I hope what I will explain will help you understanding what you have to do. So to find whether the word new doc of K is already contained in index, I advise you create a cell array of all the words that are contained in index using a comma separated list. So you will be writing something like a comma separated list inside curly brackets. And so the comma separated list will, so the things that is contained inside the curly brackets will be a function of, will be computed from index. So it will be index dot something, and this comma separated list will give you the list of all the words that are contained in word cell in the index. Sorry, and then I advise you use the function string compare I to see if new doc of K is listed in word cell. So string compare I has there is a specific case where you can use string compare I, where the first argument is a character and the second argument is a cell array. So this is perfect for us, and I suggest you use that in your function. And this will basically give you a logical array filled with zeros and ones, and the zeros will be where the character array is not equal to the corresponding element located in the cell array, and one will be when both are equal, right? So I suggest you have a look at this string compare I function and how you can use it with a cell array, and this will probably help you to do this step. Okay, and once you have this array with zeros and ones, I suggest you use the function find to find the elements that could be equal to new doc k. Okay. So here I suggest to find whether new doc k is corresponding to a word that is already contained in index, I suggest you use the function string compare I and the function find. And in any case, be careful with string comparison. Don't use the equal equal. And so this careful does not apply if you use string compare I, but if you want to do it in another way, be sure you don't use the equal equal. And also, it doesn't matter if the letter are uppercase or lowercase, so make sure you handle that. Okay, so now we have compared the new doc of k with the elements, the words that are already located within the index. There's a string compare function that doesn't care about case. Right, yeah, so string compare I doesn't care about case. So you can this one is a perfect function to consider. Okay, so now we know if new doc of k is contained in the index. So we stored this hypothetical index, this possible index in IDX, right? So it's in the middle of my paragraph here, but I will put it in red. So IDX will be either a 1 by 0 double array if the word new doc of k is contained in index in the object index, or IDX will be a 1 by 1 array containing the corresponding index for the element if new doc of k is contained in index. So if index is empty, we know that new doc of k is not listed in the index and that we should add it to the index. So for that, you can use index n+1 dot the corresponding field name. So I'll put that inside parentheses so that you're not confused. So the corresponding field name. And remember that the field word contains the lowercase version of new doc c. And then what you want to do is, in that case, is also update the field's documents and locations of index of n now, because you already added the new word to your index. So now this new word is contained at index of n, and you want to update the document by adding the number docnum, and update the location by adding the corresponding index. Okay. So now, if IDX is non-empty, it means that the word new doc k is already contained in the index. So now there are two cases. The first case is that the word has already been used in the new document, new doc, so that we have like we have already read this word previously. So in that case, what you want to do is just add the location k you're considering, right? Because it's new doc of k. So add the location k to the cell array where you store the locations within the document. And if it is the first time that the word new doc k is used in the new document new doc, then you just want to add the location k to the cell array. Okay, so you want to check if the word has already been used in new doc. So for that, you want to check if the number docnum is already contained in index document. And then if it's not contained, then you add the doc number to the corresponding array, and you add the location to the corresponding array. And if it's already contained, you just want to add the location into the correct cell array. Okay, so for this exercise, you are provided a lot of examples. So I suggest you really first start by reading the example and make sure you understand what the exercise wants you to do. And second, the examples will also help you to make sure that your code is computing and that you're having the right types of brackets at the right locations, etc. Okay, and in the end, you are also given a pseudocode. So I've just expanded that in my discussion notes here, and I've been more specific about the type of functions you should be using. So yeah, make sure you understand the structure of the program, and then really focus on the way you should be implementing it, like the things you should be typing so that your program works. Okay, so that was it for exercise 3. So now I'm moving to exercise 4, which is the last compulsory exercise of this assignment. Okay. So in exercise 4, you are manipulating the same index, basically. And you want to do the opposite operation, that is, if you're given a list of words, you want to find the documents where these words are contained. So in the previous question, you had a document and you wanted to add this document to index. And now you have index and you have the words and you want to find the corresponding documents where the words are contained. So you want to return the document number that contain all the words that are given as arguments of the function. And this all is important. So the input words can be either a character array representing a single word, or it can be a cell array containing multiple cells, and in each cell would be stored a specific character. So I would suggest here that the first thing you do inside your function is check for the type of words, for the class of words, sorry. So if word is a character, you can use the function ischar to find that. So the first step is that you check whether the argument word is a character array or a cell array. And so that the rest of your code is unchanged, I would suggest that if you see that is a character array, I would suggest that you transform that into a cell, a 1-by-1 cell. that contains only one field, which is the word that is given as argument. And so that for the rest of the code, you don't have to worry about whether words is a character array or a cell array. This will be the same. It will be the same because now you know that words will be a cell array, and you won't have to be doing different cases, etc. So it will just be easier for the rest of the code. Okay, so the logic of this exercise here is that you will be going over the different elements of the that are contained in the cell array words, and for each element you will be you are going to look for the number of documents that are corresponding to this word. And so for that you have to use the index object, which basically stores the number of documents, the number of the corresponding documents. So for each word, you will be having a corresponding list of documents. And because you want to find the documents that contain all the words, you will be computing an intersection of all these documents. So you will be, each time you will be intersecting the new document list with the document list that you already had before. So before going over the different elements of words, I suggest that you initialize matching docs with all the documents that are that contains all the document numbers. Oops, sorry, no, forget what I said. So don't do that at the second step. So the second step will be to loop over all the elements of words. So you will be writing a for loop here. And you will be considering the character array that is contained at location I of the cell array words. And so for that one, you will be finding the corresponding indices of the elements index.word. And so this step is very similar to the step you did in exercise 3 when I advised you use the function string compare I and the function find. So after that, you will be in IDX, you will be having the indices corresponding to the places where the word is contained in index. Okay, so if IDX is empty, it means that no document contains the words of I. So matching docs, you should set it to be an empty array. And so this is like the simplest case. And the other case is that IDX is non-empty, so it contains one element, which is the index where the words of I is contained in index. So then matching doc should be the intersection of the documents that are contained in index IDX of documents and of the former matching docs that you computed. And for that, use the function intersect. Okay, and for that, be careful. There is a special case when I equals 1, because you don't have the former version or matching docs. So when I equals 1, you can just set matching docs to be equal to index IDX of documents. All right, so I hope that will help you with exercise 4. Okay, so Mark, I can be answering your specific questions. I'll go quickly over exercise 5 and 6 that are optional, and then I can be answering your question. So for exercise 5, you have to write a special type of a function that does a special type of intersection, which is called index intersect, and it might be little bit strange why you have to write this function like that, but you will understand why this function is doing that in the next exercise. So just try to write the function as explained, and don't try to understand too much why you're doing that. You'll be understanding that in the next exercise, in exercise 6. And I have no idea when the 5 and 6 are going to be due. Sorry, I don't know more than you on that. So index intersect has 4 elements, four input arguments. So D1 and D2 are numeric arrays, and L1 and L2 are 2 cell arrays. And what you want to do is compare the elements of D1 and D2. And in the case when you can find elements in common, then you want to update the nd and int d and int l arrays in the way that it's explained in the homework. So what I would suggest to do here is that you will have to write a for loop that, for example, goes over the different elements of D1, and each time in the for loop you will be comparing the element of D1 with all the elements of D2. But before writing that for loop, so you can initialize the array int d and int l to be empty, and then so in your for loop you will be going, for example, over the elements of D1. And so when you consider D1 of I, you will see if any element of D2 is equal to D1 of I, and you will store the corresponding indices in index. So once more here you can use the function find. So really you'll see that the logic of the exercises is very similar from one time to the next. So here exercise 5 is here the element when you will be finding the elements of D2 that are equal to D1 of I, it's similar to exercise 3 when you were looping over the different words that were contained in the index and finding whether one element of one, so finding whether the word was already contained in the index. So here you will be looping over the element of D1 and looking if the element you're considering is contained in D2. So for that, once again, you can be using the function find. And once again, here you have two cases, if IDX is empty and if IDX is non-empty. So if IDX is empty, that means that there is no common element. It means that D1 of I is not contained in D2, so you shouldn't be doing anything. And if IDX is non-empty, you want to compare the contents of L2 at IDX and the sum of 1 and of the contents of L1 at I. And then if the IDX is non-empty, then you update the value of int D and int L. Right, so I won't be going more into detail for this exercise. I hope that the pseudocode here that I wrote will be helping you doing that. And so for exercise 6, you will be writing another function that still use the object index. And it's very similar to the exercise 4 when you were looking for words inside the index, except that time you are looking for whole phrases. So you will be looking for multiple characters that are in the correct order and next to each other. So the basics of this function is the same as in exercise 4, except that the testing that you will be doing will be a little bit different. But you can start from the function of exercise 4 and change that and arrange the exercise 4. Okay, so oops. So the argument phrase is a cell array, and the index object is a very similar object to what we were working with in exercises 3 and 4. So in this exercise, what you want to do is going over the different elements that are contained within the cell array phrase, and you are going to compare the words that are contained in phrase with the words that are contained in index word, and you will find the corresponding indices and store them in IDX. So you see it's very similar to exercise 3 here. So if you consider the first word, so this would be phrase curly bracket of 1, then you are going to find the documents that contain this word phrase 1, and you are going to store the corresponding document in matching docs and find the corresponding locations and store in the variable location. And matching docs and locations are the two outputs of your function. So for the first word, this is what you should be doing. Then for the next elements, like for phrase 2, for example, you will do the same thing, find the documents that contain the word phrase 2, and also find the corresponding locations. And then you will have to intersect these documents and these locations with the documents and locations that you previously computed. And here you will see that the function intersect that you wrote in exercise 5 is very similar, is very useful. Because basically you will want that the document numbers are the same. So the document number can correspond to D1 and D2 in exercise 5. And you will be also comparing the corresponding locations. And you want that the locations of phrase 2, you want the word phrase 2 to be located after phrase 1. So the location of phrase 2 will be 1 plus the location of phrase 1. So basically you will want that the element of L2 are 1 plus the element of L1. And this is why you will it will be able here to directly compute the intersection with the function index intersect. Okay, and so once you know how to do it for the first word, phrase of 1, the second word, phrase of 2, then it will be same procedure for phrase 3, phrase 4, until the end. Okay, so you will be going over the different elements that are contained in phrase, and you won't be doing the same thing whether the element is contained, so whether phrase of, so you will be considering the different elements phrase of I, and you won't be doing the same thing whether I is equal to 1 or I is equal to something else. Okay, so you will have an if statement inside your for loop. All right, so that was what I wanted to say for the salary exercise homework. So yeah, good luck with that and come to the lab sessions for your question.